Hi everyone, this is Kiranmay from H&S department. Today we are going to discuss about dielectrics. In that, we are going to discuss what is a polarization, different types of polarization, and from different types of polarization we are going to derive an equation called as Langevin-Debye equation. Coming to polarization, polarization is a phenomena in which when a dielectric material is placed in external electric field, the positive and negative ions of the material will displace in opposite direction due to the application of external electric field. This displacement of ions or positive or negative charges in opposite direction is called as polarization. How much polarization is there in a given material that can be calculated using a vector called as polarization vector, and which is defined as the ratio of induced dipole moment per unit volume. Due to the application of electric field, the positive and negative charges will get displaced in opposite direction, forming dipoles inside the material. Due to the formation of these dipoles, dipole moment exists in the material, which is called as induced dipole moment. That induced dipole moment per unit volume in the material is called as polarization vector. And if you substitute the formula for dipole moment, that is charge into distance between the poles, that is q into 2l by volume as area into length, you can cancel length terms, so left off with charge per unit area. So polarization vector is otherwise defined as induced charge per unit area, and the units are coulomb per meter square. This polarization, depending upon the given material of dielectric, there are three different types of polarizations especially. So there are three mechanisms by which polarization can occur in dielectric materials when they are subjected to external electric field. They are electronic polarization, ionic polarization, orientation polarization. First of all, what is an electronic polarization? See, on the application of electric field, as we discussed that polarization is nothing but a displacement of positive charges and negative charges in opposite direction due to the application of electric field. As in electronic polarization, if the positively charged nucleus and the negatively charged electrons of an atom get displaced in opposite direction due to the application of an external electric field, is called as electronic polarization. Since the nucleus and center of electron cloud are separated, the dipole moment is created in each atom. Therefore, induced dipole moment is directly proportional to applied electric field. P is proportional to E. If you remove the proportionality, you have to place one constant, alpha E, which is called as electronic polarizability, which can be derived using the formula 4 pi epsilon naught R cube. Now, from this formula, it is clear that electronic polarization is independent of temperature and is proportional to the volume of the atoms, and also takes place in all dielectric materials. Then coming to ionic polarization. This ionic polarization exists only in the materials which are ionically bonded, dielectric materials which are ionically bonded, such as sodium chloride. In such materials, when they are subjected to external electric field, there will be a displacement of oppositely signed ions, that is positive ion and negative ion, in opposite directions. Hence, such polarization is called as ionic polarization. So ionic polarization is due to displacement of cations of mass m and anions of mass capital M in opposite direction. Therefore, induced dipole moment is directly proportional to electric field, and proportionality will give you one constant called as ionic polarizability, whose value can be determined using E square by omega naught square into 1 by small m plus 1 by capital M. So from this formula, it is clear that ionic polarization is inversely related to square of the natural frequency of the ionic molecule, and also directly proportional to reduced masses, and is independent of temperature. So therefore, electronic and ionic polarizations both are independent of temperature. Whatever the temperature changes will be there, that won't affect ionic and electronic polarizations. Coming to the orientation polarization will be exhibited only in the polar dielectrics. Then what are polar dielectrics and what are non-polar dielectrics, that we will see in the next continuation session. This specially orientation polarization exists only in the polar dielectric material. When they are placed in external electric field, they tend to align themselves into the field direction. Hence, such alignment polarization is called as orientation polarization. Since induced dipole moment is directly proportional to electric field, orientation induced dipole moment also proportional to applied field. PO is proportional to E, PO equal to alpha naught E, where alpha naught is called as orientation polarization, which can be given as mu square by 3 kT and is dependent on temperature. So orientation polarization is inversely proportional to absolute temperature of the material. So from this, another type of polarization which exists in materials, that is space charge polarization, due to diffusion of ions along the field direction, gives rise to redistribution of charges in the dielectric material. Such polarization is called as space charge polarization, but it will be occur in very small quantity, hence it can be negligible. Coming to the total electric polarization, that can be the sum of electronic, ionic, orientation, and space charge polarization. So among them, space charge polarization is small compared to others, so it can be neglected. So therefore, total polarizability can be given as sum of electronic polarizability plus ionic polarizability plus orientation polarizability. So alpha is equal to alpha naught plus alpha E plus alpha I, where alpha is electronic polarizability, depends on volume of the material. Alpha I is ionic polarizability, depends on frequency and reduced mass of the material. And alpha naught is orientation polarizability, depends on temperature of the material. So summation of them will give you total polarizability. So suppose if the material is having n number of atoms, then polarization is given as P equal to n alpha E. So in place of alpha, just replace it with total polarizability. You'll get P is equal to n into 4 pi epsilon naught r cube plus E square by omega naught square into 1 by 1 plus m plus mu square 3 by 3 kt into E. This equation is called as Langevin-Debye equation. Coming to the polar and non-polar dielectrics, the molecules in which center of gravity due to both positive and negative charges coincide are called as non-polar molecules, otherwise polar molecules. Polar molecules means the center of gravity due to both positive and negative charges does not coincide with each other. Hence, it forms dipoles. Hence, it can be polarized very easily. For non-polar molecules, the dipole moment will be zero and they have symmetrical structure, whereas polar dielectrics, the dipole moment is permanent and they are unsymmetrical structures. Symmetrical structure means when it is rotated along the axis of symmetry, the structure will be resembled in the same manner, whereas when the unsymmetrical structure is rotated along the axis, it cannot resemble the same structure. Thank you.